So in the end of our last episode, which returning viewers will know is the war cry I make at the start of every episode where I need to correct something that shouldn't have been a mistake that I've made anyway, but I digress. In the end of our last episode, we highlighted that my upper arms are, what's the word? Useless. Let me recap using the power of art. Right, I'm fairly sure that art is pretty much an apt explanation of what's going on, but for those who are not automotively inclined or can't understand my attempt at drawing, that's a tyre, that's a upright, upper wishbone, lower wishbone, and a spring. Okay? So what I'm facing right now is a problem whereby this doesn't really sit like this at all. To over-accentuate the problem, it sits more like this. That is to say, it has far too much positive camber. By being more that way from the centre line of where the wheel should be, that would be zero camber, and this is, well, I don't know, plus 20 degrees or something. That's not too wild an assumption from what it is in the car. Believe me, it's wildly out, but we'll take some proper measurements in a while when we get into this. The problem I have is my camber's adjusted here on this little adjusty thing that we built many episodes ago, and allows us to unscrew to reduce camber or screw in to increase camber. The problem I have is there is about this much meat left for me to unscrew with, and already that's a very dangerous position, because if there's not a lot of thread in there, it means that A, that's shearing quite easily because there's not a lot of meat holding it on, and B, we can't really sort the problem using this, so I need to look at some other options. There's not many of them. Let's take a more focused view on what's going on in this. This is our ball joint, specifically a Mark III tie rod, which has been used as an upper ball joint. This and this are the intersections that secure this ball joint into here. How does it work? Well, that's a lock nut, more or less. So we run that onto the very end of here, put it in, and then running this in, the differential between these two will set the depth that this goes in and out of the arm, which gives us our camber adjust. Actually not a really bad idea. The issue I have, well, the first one, now I don't know if it was because I welded it wrong, used the wrong diameter pipe or what, but my actual pipe comes in pretty close to where this meets. Now you'll note here that there's a shoulder, and this actually has a hex on the end to allow me to adjust. Well, in one instance it actually doesn't. I've had to weld on a hex here and make this entire thing closed just to get any form of adjustment in this. Now, that's not really a big problem, but when I did that, it should have been a big alarm bell. This isn't right. There's something not quite working in the design, because the book did specify that this should work. But in practice, it doesn't. So the other problem is that adjuster has to be on here, and this has to engage in this thread. Now at the moment, I may be getting to here, and then I'm all out of adjustment. And bear in mind, this has to come out further than this in order for me to actually dial out the camber. So what we need to do is figure out a solution. Option one is to redo this in its entirety. Now, I'm not really against that, because altering this would mean I could put in some improvements. Bear in mind, this project has evolved, and so have my talents, so we could actually think about just making this fully locked and having our camber adjust happen here, and then putting rose joints on and all sorts of craziness. But, well, my problem with that is then I've only got one of these fixed with rose joints. The other four, i.e. the two rear uppers, the two lower uppers, and the two front lower arms, well, they're still poly bushed, not rose jointed. So there's a bit of an imbalance there, and OCD's not going to like it. Option two is we cut this out and just deal with it properly by moving this entire assembly to fit further out. Obvious problem, this would need a complete redesign. This would need a complete redesign, because in order for that to move, I'm going to be deeper into my problem than I was before. Option C, you'll have seen arms like this before. We do a complete redesign, reuse this, move the whole thing 30mm that way, and put on these sort of, bent tubes. Problem with this, cold rolled steel, bending it, mandrels, pain, misery, death, horror, and fundamentally project creep. What is option 5? We pack it in and cheat. When we put our full assembly together in the wishbone, it looks a bit like this. So that's the socket I need. This being our ball joint, let's say hypothetically this is where it actually needs to sit. How do we make this go deeper into here? Bear in mind it's threaded, it's also a manufactured part. Adding on metal from here forward means a full retap, some pretty cunning welding techniques, and a fear The fear being, well, how good's my welding? How long is this going to last? Also, if the ball joint itself ever fails, it means I need to redo that process every time we replace what is a consumable part. Nah, I don't like that one. So we need to cheat harder. We just extend it. Get Chaz and Dave off right now. The one Hail Mary I have for this is these are not ball joints. Well, technically they are ball joints, but they are not the usual ball joint arrangement. These being Mark III Transit tie rods are technically steering rack components. Now, the good part about that is there are companies out there that do steering rack extenders for literally a plethora of applications. I think this is a drift thing, extending your steering rack for whatever reason. We've actually done steering rack extenders on our own steering rack, but the beauty is I can add material here by simply chopping this down, so I've got an inch left, and remaking that with even more thread, which will tip this out. There are also companies that do custom made ones because, believe it or not, there's not many people that drift Mark III Transits anymore, or ever did in the first place. So I digress. Let's have a look at how much I need to extend this and then see if we can get something custom made up. So my total amount of, if I had the perfect ball joint right now, would be 110 millimeters. So really, I think that's probably going to be the best total length I can get away with. Because remember, on that side we've capped that with a bolt, so I wouldn't actually get 110 mil in here, but I want to use the maximum amount of thread on this guy that I can, and have as much on here that I can get away with as well. So if I was to have, say, 25 millimeter there, and the rest of that as thread going into here, we'll be good. But there's a problem with that. Because if I have a total length of 110 millimeter, and I have this as 25 millimeter, then that would it be all thread? Except it wouldn't, because there'd be a great big hole here and no meat there. So we're gonna have to have a level of actual metal here sacrificed to strength. So would I get away with that? No, because that's 110 total. So if I was to do a 65 and a 45 split, would that work? 65 would take me to there, that's plenty of meat. 45 would push me out to here. That might be a wee bit tight, but that's all I'm going to get away with because I really don't want to be sacrificing any more strength on this. If this guy needs to go further in, the last thing I can do to cheat my way is drill into it and chamfer so that we actually put the body of that further out and move this further in. This is all getting a bit kind of drawing boardy heavy. I know what I need to make, I know what I need to order. Let's get it ordered. Now this is great and all, and I'm very tempted to just keep assembling things onto the front and working front to rear, but we're a wee bit front heavy. And that's because of the way I've designed this jig. Now remember, it's sitting perfectly balanced in the middle, and that was a whole thing, and we were very, very cautious with this. Unfortunately, the way I started to build this, all of this cast iron engine weight is in front of that. We've got a gearbox in the middle of it, and bugger all behind it. So, before we do anything more here, let's start looking at things in the back. If nothing else, just to balance the weight. If you think the front was a long-winded process to get an engine in, wait till you see what's involved with the back. Obviously, these wheel bearing carriers on the rear are of an indeterminate age. That means, in my book, they are 5 minutes away from failing. New wheel bearing times on both sides. That will at least allow me to put the upright into the upper and lower wishbones and put a bit of weight on. The problem doesn't stop there though, because whilst I'll be able to put those on, I still can't fully connect them because we need to put drive shafts in once the diff's in, which currently isn't in, which we don't have ready yet. But at least I can loose assemble these and it'll put a bit more ballast, frankly, on the back. So, first things first, wheel bearings in. Well, that was super dull, but very, very necessary. So next thing we need to do is look at the same again for the other side. But that is also going to be dull. So why don't we just build this up and see how far we can get. First thing we need to remedy is my utter stupidity when I bought very early model rear discs. Now we've covered this in MX5 a number of times. There are two types of discs that go in the back of the NB, and there is a small one and a large one. Naturally, we want a large one, and I've designed the back brakes to be that. So buying new discs that are small ones are, what's the word? Stupid. I do have the proper discs for the back ones. Well, I've got to say, that's not bad. We do have some pluses and some negatives, so good point. Everything seems to have bolted up well, so much so that I think the lower arm and the shock are now going to be permanent fixtures, because we can actually work around that if we need to take the hub off or anything else. That doesn't even move, so I'm going to knit them up for good. The fitment's good, I like it, it's all nice, there's no fouling, so good. Similarly, those are the right discs. That's great. We can actually chuck the pads in and be done with that, but we can't. So I'm not going to final fit this yet, because there are some things, some little snags, some problems that I'm going to have to deal with. Firstly, we cannot final fit all this because the drive shafts need that loose. Similarly, I don't want to put wheels on because I think that's what's buggered the last set of wheel bearings. You need to have the CV joint in order to compress the bearing. Otherwise it's just loose spinning, and it doesn't like that. Some other failure modes. The top bush is horrid. This is very common, and I keep forgetting that these top bushes are the only MX5 bush part that remains, so I'm going to have to order a couple of those, press them out. But as you remember with the MX5 project I'm doing, it's actually something I can probably do on the car. I'm not going to get too hung up on that. So all in all, that's actually went quite well. So much so that I'm ready to just snap the thumb and show you what the other side looks like. Those should work in principle. However, I'm still going to have to shorten these, and that is going to be where the brave pills come in. That is a massive improvement. The only problem I've got now though is, rather than not having enough thread left to actually put it to zero camber and having nothing but positive camber, I now have a situation where the best I can achieve is zero camber and all I can do is positive camber. So yeah, my ability to put negative camber now is completely nil. But I have thought of this, do not worry. As you'll note, we've put as much thread of the ball joint back into this guy as we possibly can. Now, I don't need all of that. What we can do is shave some of this down and some more of the ball joints thread down and give ourselves more. And by much, I mean maybe a mil or two, and that will make a massive difference to the camber that I possibly can need in the front, of which we are talking a degree or two at best. So it's not going to have a huge impact. All I've done really is fire these on with an eyeball measurement to see how they do. And as luck would have it, it's nearly bang on zero. So perfect, that's fine. I'm going to fire this one on. Also, you'll note we've put bushes in the back. You'll note they are not polyurethane. They are standard MX5 ones. That's because, well, that's all it really needs. I just want fresh bushes. There's no point in putting polyurethane in everything. It'll do, it'll match. If I feel like it's still loose in the back end and that's an obvious cause, we'll deal with it. But I don't, so we won't for now. We are very close to putting wheels in the back. In the next episode though, I need to deal with adding more weight to balance the jig. So that means we're gonna have to think about diffs. Great. So that's exciting, obviously, because what I'm doing with this car is certainly not what I've done with the MX5. So therefore, any diff mods, well, that's getting done by me. So stay tuned for that. Anyway, for the moment, I'm gonna go finish off the ball joint extenders and the bushes on this side of the car. But there we go, progress, good progress. Until next weekend, guys, make sure you check out patreon.com/toolsandtrack, because that's why you've not seen an ad. It also just helps support all of this build. So, you know, if you like it, you find it useful, chuck us a couple of quid on that. That'd be grand. If not, cool, I get it. It's tough times for us all. But just do the like bell, subscribe, and the share thing, because that costs nothing, and I would still appreciate it. So, cheers. And until next weekend, guys, drive safe.